Right. Good afternoon. So today's session will be the continuation of what we have done in the class physically. So up to now we have discussed about uh, hydrogen spectrum, right? So we discussed that hydrogen emission spectrum is a line spectrum, and we discussed what is a absorption spectrum and what is a emission spectrum as well, right? Uh, So by the way, if there are any questions during the class, you can unmute yourself and ask any questions. Since this is a live session, so you can ask any questions like same as in the class, right? So uh, I can't see you guys, but don't fall asleep. Just focus on class, right? Now, the hydrogen emission spectrum and hydrogen absorption spectrum, now we need to analyze it further, why it is happening, what is the reason for it, right? So uh, people thought of why this kind of things are happening, what is the reason that we can see on the four lines in the hydrogen spectrum, right? So if you talk about those four lines, the four lines are having four colors starting from violet, blue, blue green, and red, right? So we discussed that red one is having the highest wavelength and violet is having the shortest wavelength. Or in other words, violet is having the highest frequency and red one is having the lowest frequency. People wanted to know why this is happening. Now we know that in our scope, uh, the color is a frequency. A color is a frequency that is coming from the hydrogen emission spectrum, right? So hydrogen emission, from the hydrogen emission spectrum, we can understand that that is also a frequency. And electromagnetic spectrum gives us the idea that colors are also having a frequency. So we can combine everything and we can say a line is corresponding to a frequency. So this frequency means it is having a energy. So how this energy is developed for a hydrogen atom? That was the idea. That was the discussion during that time, right? So then they came up with the idea of energy levels. Energy levels, right? Now let's try to understand what is an energy level here, right? Let me share the screen. Right. Hope you can see the screen as well. My online classes are like this. I know that this is not natural, but natural class එකක් වගේ මගේ setup එකකුත් තියෙනවා. ඒකේ පොඩි lighting ප්‍රශ්නයක් තියෙනවා. So that's why I started do the class like this. So if there are any questions, just ask me. If this is not convenient for you, then we can discuss further on this matter. Now, now we know the hydrogen emission spectrum is having four colors, right? So one is having red, other one is having green and violet. Sorry, blue, something like this, blue and violet, like this. So in this direction, frequency is increasing, lambda is decreasing. So this is a line spectrum. Line spectrum. Right? Now, people wanted to understand how this is happening. What is the reason for it? So they came up with the idea of the energy levels. What are the energy levels? Now we have the nucleus here. Then around the nucleus, there are energy levels, right? So energy levels, here we have one energy level, which is closest to the nucleus. Then we have another energy level. These are circular things around the nucleus. Then the third energy level is having, let's say second energy level is somewhere around here. The distance between third energy level and second energy level is smaller than the energy level between first energy level and second energy level. Let's say this is E1, this is E2. The distance between E1 and E2 is greater than the distance between E2 and E3. So E3 will be somewhere around here. Then E4 will have further closer to E3 than E2. This is E4. And this is E5. Then E6. So all are circular things around the nucleus. Circular things, right? All are circular. Then there are infinite number of energy levels around the nucleus, right? So in this direction, from nucleus to outwards, from the nucleus to the outward direction, energy is increasing. In this direction, energy is increasing. I'm talking about the energy level concept. Energy is increasing. So let's say the energy difference between E1 and E2, let's say it is X energy level difference. So each level has an energy. That's so let's say this is A, this is B. So B minus A, of course, B is greater than A. Then we can perform a formula called B minus A. So let's say this is X. So this is E3 minus E2. Let's say, sorry, yeah, E3 minus E2. So let's say this is Y. So this X and Y gives you the idea, the energy difference between the two levels. X is the energy difference between E2 and E1. Y is the energy difference between E2 and E3. In general, from nucleus to outwards, energy of each level is increasing, right? So the electrons, the scientists told that electrons can be in one of these or any of these energy levels. It cannot be in between these energy levels. That was one of the theory coming from Bohr theorem. Bohr theorem එකේ in detail explanation එකක් මේකෙන් පස්සේ දෙනවා. දැනට මතක තියාගන්න. Electrons can be in one of these energy levels, any of these energy levels. Energy level එක මොකක්ද කියලා decide වෙන්නේ based on the energy of the electron. If the energy of the electron is very high, it will be higher energy levels, that is somewhere around here. If the energy of the electron is low, then electron will be somewhere around here, because these are having lower energy. So we learned two things now. There are energy levels, they have energy, and based on the energy of the electron, the energy level that electron is in will be decided. If the electron is having higher energy, it is in a higher energy level. higher energy level. If electron is having lower energy, it is in the lower energy level. Right? Now, lower energy levels are more closer to the nucleus. Higher energy levels are more distance, having a more distance from the nucleus. Now, දැන් මේක හරියට නිකන් මේ වගේ දෙයක් පුතේ. අපි හිතමු නිකන් පඩි පෙළක් ගන්නවා කියලා හිතමු. දැන් ඉලෙක්ට්‍රෝන එකකට ඉන්න පුළුවන් මේ එනර්ජි ලෙවල් එක විතරයි. එයාට මේ in between ඉන්න බෑ. ඒ කියන්නේ he can't somewhere around here. He can't be in somewhere around here. In between. He can't be. That is coming from the theory. Right? කියන කතාව හොඳට තේරුම් ගන්න ඕනේ. In between නෑ. කොහේ හරි නිකන් එනර්ජි ලෙවල් එකකට වැටෙන්න ඕන අනිවාර්යෙන් ඉන්න ඕන. නැත්තම් එයා මැද ඉන්න බෑ. This is coming from the both theorem. මේක නිකන් හරියට තේරුම් ගන්නවා නම් අපි පඩි පෙළක් නගිනවා කියලා හිතන්න. එතකොට පඩි පෙළක් නගිනකොට ඔය අපි අනිවාර්යෙන් පඩි පෙළක ඉන්නවනේ පඩි පෙළ නගිනකොට. ඒක පඩි පෙළවල් එක දෙකක් අතහැරලා ඉන්නවා වෙන්න පුළුවන්. පඩි පෙළවල් දෙක තුනක් අතහැරලා ඉන්නවා පුළුවන්. හැබැයි අපි පඩි පෙළක ඉන්නේ. පඩි පෙළ නගිනකොට මොකක් හරි එක පඩිය වෙනවා ඉන්නේ. මේ පඩිය නිකන් එනර්ජි ලෙවල් එකක් වගේ. ඔයාලා පඩි පෙළ පයින්නවා කියලා පොඩි කාලේ කරලා ඉන්නේ. එතකොට දැන් දෙක තුනක් පැනලත් ඒ තියෙන්නේ පඩියක තමයි. අතරමැද ඉන්න බෑ. This is the analogy that you can understand. Right? කොහේ හරි ගිහිල්ලා පඩියක තමයි ඉන්න ඕනේ. Electrons are also like this. Now, let's talk about uh, the natural scenario. Again, hydrogen as it is without doing anything. That means the ground state. I have explained you the idea of the ground state. That means it has not absorbed any energy. Ground state. Ground state කියලා කියන්නේ you have not absorbed any energy or hydrogen is not absorbed any energy. මේ මොන energy එකක් absorb කරත් there is no change to the position of the protons and nucleus that is within the nucleus. Protons and neutrons within the nucleus, there will be no change to the position of those things. So energy will impact to the position of the electrons. So position of the electrons will be decided based on the energy of the electron. Now ground state. Ground state means the lowest energy of the hydrogen electrons. Lowest possible energy. So it will be in the lowest energy level. Let's say there is only one electron. If it is one electron hydrogen is having, it is in the lowest energy level because in the ground state, it is having lowest energy. In the ground state, it is having the lowest energy. That is the idea. Now we supply energy. We supply energy. When we are supplying the energy, it absorbs energy and it will increase the energy. Now, how it is absorbing the energy? In quantum levels. Quantum packet wise, it is absorbing the energy. Right? So, it is absorbing energy and it is enhancing the energy. So, that may enhancing the energy උනාට පස්සේදී ground state එකේ අපි තුමු E1 මේ E1 කියන එක ගත්තොත් E1 එකේ energy එකට වඩා එයාගේ energy එක වැඩි වුණොත් up to E2. Then it will jump to, this electron will jump to E2. It will go to E2. Now it is not in E1. It is going to E2 energy level. It need to absorb energy E2 minus E1. It need to absorb energy E2 minus E1. According to the Planck equation, this E2 minus E1 will be equal to h nu. Right? So we are talking about absorbing energy. Absorbing energy means this is corresponding to the absorption spectrum. Can you remember? We have drawn a diagram that hydrogen is in ground state and we are having energy here, energy source, and we allowed to go through this prism and we monitor, we observe that there are some frequencies are not there. Some frequencies are not there. දැන් මේ නැති frequency ටික තමයි මේ මනුස්සයා මේ absorb කරගෙන තියෙන්නේ to go into the higher energy level. So this frequency nu is the frequencies which we can't see in the absorption spectrum. So we are talking about how the absorption spectrum is created. Now we are supplying furthermore energy, right? Supplying furthermore energy. So there can be some situations where this electron is absorbing enough energy moving from E1 to when electron same electron. There can be some scenario, it is the energy is enough, the absorbed energy is enough to move into E3. Yeah, very poor energy would absorb because E3 minus E1 should be higher energy. So this energy is E3 minus E1. This will be H nu 1. So nu 1 is greater than nu, sorry, let's say this is nu 2. Nu 2 is greater than nu 1 here. So this is E3 minus E1. There can be some situations when the electron is in E2, same electron I'm talking about. There can be many situations, right? So this electron may be in E2 and energy is absorbing and it is going into E4. When the absorbed energy is enough or matches with E4 minus E2, then it is going to E4. So this is what happens to the same electron. Let's say it is having only one electron. From all your knowledge, you know there is only one electron for hydrogen. So hydrogen can be moved into different energy levels during the absorption energy or absorption spectrum creation. It is called as absorption spectrum, right? So if this frequency, I told you that in the electromagnetic spectrum, there are some frequencies which we can see. There are some frequencies which we can't see. For example, ultraviolet ones we can't see. Infrared we can't see. So if something is in the visible range, if this E2 minus E1 or E4 minus E2 energy is matches with H nu, if nu is within the visible range, that frequency we can see. Right? So, but when absorption spectrum is created, that frequency will be absorbed. Then we can't see that. Right? There can be some scenarios where this electron, where this electron is gathered energy to move into the infinity. For an atom, infinity means outside the atom. So which means it is going out the atom. So energy is absorbed. That energy is enough to go into the infinity, to reach the infinity, which means electron is going away from the atom. Electron is removed, electron is released. That also can be happen. Then electron will not be within the atom anymore. So in that scenario, this electron will be moving from E1 or anyone else into the infinity. So which means electron has gone from the atom. So it is not in the atom anymore. Right? So many scenarios can happen. The scenarios will be based on the energy which is absorbed during the absorption. Still, we are not talking about the emission. We are talking about the absorption spectrum. Right? Any questions up to now? If there are any questions, you can unmute and you can ask any questions. Right? Now, this is what happens in the emission spectrum. From low energy levels, they are moving into high energy levels. Right? Now, we remove this energy source. We remove this energy source. Then what happens is, as I told you, our even humans as us, we can't be in high energy levels. අපි හිතමු high energy level එකක් කියලා කියන්නේ අපි නිකන් එනම excite වෙලා ඉන්න අවස්ථාවක් කියලා. අපි excite වෙලා ඉන්නවා නම් අපේ කුතුහලය වැඩි නම් ඕක exciteness එක යනකම් අපිට ඉන්න බෑ. අපි කොහොමද ගෙදරට මොකක් කරේ තෑග්ගක් ගෙනාවා. අපි excite වෙනවා. අපිට කුතුහලය වැඩි වෙනවා. මේක මොකක්ද කියලා බලන්න හිතෙනවා. ඕක තියෙනකම් අපි එහෙන excite වෙලා ඉන්නේ. ඕක කඩලා මොකක් කරේ බලපුවම exciteness එක බහිනවා. අපි කනවා කියලා හිතමු. හොදට කාලා අපේ එනර්ජි එක අපි වැඩි කරගන්නවා. එනර්ජි එක වැඩි කරගත්තට පස්සේ මොකද වෙන්නේ? ඕක ඉන්න බෑ ඉතින් ඇඹරෙනවා, හැරණුම් යනවා, බුද්ධිමත වෙනවා. මොකද වෙන්නේ? Our body is saying us your energy is high. Make sure to reduce your energy. ඊට පස්සේ නිදා ගන්න බලනවා, නිින්ද යනවා. කොහොම හරි කරලා මේක එනර්ජි එක අඩු කරගෙන තමයි බලන්නේ. Right? So as humans as when energy is increased, when we are in the higher energy levels, then we always try to release the energy and come back into the low energy levels. Right? So here for electrons as well, the main situation now electrons are not in the ground state, now electrons are in the excited state. They have absorbed the energy through the absorption spectrum or absorption activity. Now they are in the higher energy levels. So the nucleus is high, nucleus is here, and these are the energy levels. Like this. Now the electrons are in higher energy levels. Right? So sometimes electrons may be in here. Sometimes electron may be here. Sometimes electron may be here. Sometimes maybe electron here. Yeah, so this is E1, this is E2, this is E3, this is E4, this is E5. So it is going up, right? I have drawn only few. Now what happens is, these electrons will release energy and come back into the low energy levels. They are releasing energy. Some electrons may fall into E2 because release energy is equal to E4 minus E2. It can happen. Those are random scenarios we are talking about. Some people are just moving to E4, for an example, I'm saying. This electron may be coming into E1. So while they are coming back, they are releasing energy. They are emitting energy. Releasing energy means that is also delta E. Delta means the difference. Here the difference is E1 minus E2 for this one. Because always antimata mena ekkena minus kalin tibbe ekana thamai ganna ඕන. So this is the final one. This is the previous one. So E1 minus E2, definitely this is a negative value. But the value is positive. Negative sign should be there. Because හැම වෙලාවෙම negative difference එක ගන්නෙ final one minus the initial one. Right? So this is also will be equal to h nu. So which means they are releasing energy. They are releasing energy, and that releasing energy is also equal to h nu, according to the quantum theory of Planck. If this nu is in the visible region, we can see it as a light. If this nu is within the visible region, we can see it as a visible light. We can see it if this frequency is in the visible region. So that's why in hydrogen emission spectrum, there are 4 lines. So which means there are only 4 lines which we can see. That is only 4 lines, only 4 energies, or only 4 energy differences, which creates the frequency within the visible range that we can see. So that's why we can see only 4 frequencies or 4 lights, 4 line frequencies in hydrogen emission spectrum. Does that mean only 4 energy differences in this process? No. There can be many energy differences. Sometimes it is coming from E equals 4 to 3, E3 to E4. So there are infinite number of energy level differences or energy differences. They are releasing infinite number of energy differences. But only 4, we can see them. Right. So this is the basic explanation for the hydrogen emission line spectrum. So during the emission, electrons are moving from higher energy levels to lower energy levels. They are emitting energy, and that energy is having some kind of frequency which we can see. Any questions? You can text if you want. My chat window will also be open. Right? Right. Now let's take down the note. Right. Let's try down. හැමෝටම සුබවෘත් අවුරුද්දක් වේවා කියන කරනනේ. Happy New Year all. Sorry. Okay, let's try down. The topic: understanding the hydrogen emission spectrum. Understanding the hydrogen emission spectrum. Increase the volume. How can I increase the volume? That's a good question. Is it okay? I will keep my mic too closer to my mouth. I think that would be fine. I will try to speak more loudly then. Right. Okay. Let's try down. Okay. Right. First bullet point. Let's try down. There are energy levels. There are energy levels. There are energy levels around the nucleus of an atom. There are energy levels around the nucleus of an atom which have a certain energy. Which have a certain energy. Next bullet point. Energy levels closer to the nucleus. Energy levels closer to the nucleus are having lowest energy and energy of the energy levels increases while moving away from the nucleus. Next bullet point. There are infinite number of energy levels around the nucleus. Next bullet point. Energy gap between two energy levels decreases when moving away from the nucleus. Next bullet point. Electrons can be in any of the energy level but not in between the energy levels. Next bullet point. When energy is not absorbed by an atom, electrons are in the lowest possible energy level. Next bullet point. When energy is supplied to an atom, electrons absorb energy and move into higher energy levels. Next bullet point. Energy is absorbed in quantum wise. energy is absorbed in quantum wise. චුට්ටක් අහන්න පුතේ. දැන් මෙතනදී අපි අර absorption spectrum එක අපි හදනකොට මතකද අපි ඇන්දේ light source එකක් නේ. එතකොට අපි කතා කරා light source එකක එහෙම නැත්නම් optical energy එකේ quantum එකට කියන්නේ photon එකක් කියලා නේ. So in here electrons are absorbing energy photon wise. quantum තමයි අයින්ස්ටයින් කිව්වේ quantum එකක් ගත්තාම optical energy එකේ තියෙන quantum එකකට photon එකක් කියලා. Right? So within brackets, let's write down within brackets. Usually energy is supplied in the form of optical energy therefore electrons are absorbing photons to increase the energy. Next bullet point. දැන් මම මේ කියන කතාව හොඳට තේරුම් ගන්න ඕනේ. මම දැන් කියවනේ ground level එකක තියෙන එකක්. right? දැන් ground level එකක තියෙනවා කියලා කියන්නේ electron will be in the least possible energy level. right? least possible energy level. එතකොට ඒකෙන් අදහස් වෙන්නේ එයා ඉන්නේ E1 එකේමයි කියලා. එයාට ගන්න පුළුවන් least possible energy එක E2 එකේ නම් එයා ඉන්නේ E2. එයාට ඊට වඩා අඩු කරගන්න බෑ. දැන් සමහර මිනිස්සු ඉන්නවනේ දැන් කාලා සමහර වෙලාවට බඩගිනින්න ඉන්න පුළුවන්. සමහර වෙලාවට බඩගිනින්න ඉන්න බෑ. උන්ට එක ලෙවල් එකක් ආවට පස්සේදී ආයෙ කන්න ඕන. නේ. ඒතකොට උගේ එනර්ජි එක ග්‍රවුන්ඩ් ස්ටේට් එක ටිකක් වැඩියෙන් තියෙන්නේ. ඒක උගේ කොහොමද එනර්ජි එකක් තියෙනවා. ඒ කියන්නේ බයි ඩිෆෝල්ට් උගේ එනර්ජි එකක් තියෙනවා. සමහර වෙලාවට ඉන්නවනේ හැමතිස්සෙම නට ඉන්න විශේෂකාරයෝ ඉන්නේ. කියන්නේ උගේ ග්‍රවුන්ඩ් ස්ටේට් එකට එනර්ජි එක වැඩි. right? සමහර වෙලාවට ඉන්නවා උන් කූල් ඩවුන් වෙලා උන් ෂට් ඩවුන් කරලාම දාන්න පුළුවන්. ඒතකොට උන් ගේන්න පුළුවන් E1 එකටම. Their energy is very low. So that's why I said the least possible energy level එකේ තියෙන මේක වරදවා තේරුම් ගන්න එපා. All the electrons are in the E1 when it is in the ground state කියලා. ඔය කෙටි ප්‍රශ්න වලට අහනවා. That's wrong. Least possible එකේ තමයි ඉන්නේ. Now let's say when they are in the ground state, right, in the least possible one, they are absorbing energy, absorbing energy, and there will be a point it is going away from the atom. That means it is reaching the infinity of the atom. Infinity of the atom කියලා කියන්නේ atom එක කියලා කියන්නේ චූටි එකනේ. ඒතර atom එකට සාපේක්ෂව infinity කියලා කියන්නේ out of the atom. Out of the boundary of the atom. Right? So which means electron is removed from the atom. මම උතන් දෙනවා ඊළඟ සාකච්ඡාවේදී ඊළඟ discussion එකේදී. So electron is released from the atom. Right? So that is also due to absorbing energy. Right? Next bullet point. When electron is absorbed energy, to reach the infinity of the atom, electron will be released from the atom. Within brackets දාන්න. උතනදී මම මේක සාමාන්‍යව දන්නේ මේ වචනේ මම කියලා දුන්නේ නැහැ. මේක සාමාන්‍යයට ඔයාලා O level වල කරලා ඇති. Within brackets this is ionization energy of the electron ionization energy of the electron. I will be explaining this one, but not a complete known in the make the Dagan, but make the Kamikabargil, then the back, watch and with the Dagan. This is ionization energy of the electron. Next bullet point. When electron is moving across the energy levels, when electron is moving across the energy levels, they will be placed in the energy levels. They will be placed in the energy levels in random structure. And it will be decided based on the absorbed energy. Right. Now draw this diagram, Putta. This one. Sorry. Total one should be whatever the things that you can see within the yellow circle. You can draw. Line spectrum के निकालता है मैं. Right. Draw this one. This is ionization energy. This is E infinity minus E1 equals H nu 3. Okay, pote digatari siraswari and let me know once you're done. No? අදගෙන ඉවර නම් මට කියන්න බලන්න. කෙනෙක් හරි කවුරු හරි කෙනෙක් message එකක් දාන්න. Then I can understand whether you have done or not. Okay, good. Shall we move on? Anybody who is drawing? එයාලා මේ කට්ටිය. ඔයාලා මේ මොකද හිතන්නේ මේ මම මේ කරන ඔන්ලයින් මෙතඩ් ඔන්ලයින් කියන්නේ මේ විදියට ඔන්ලයින් කරන එක නිකන් ඔයාලට හිතෙන විදියට මොකද නිකන් හොඳයිද හොඳ නැද්ද මීඩියම්ද what do you think? මම නිකන් නැචරල් විදියට කරන සෙටප් එකකුත් තියෙනවා අනිත් සර්වර් කරන විදියට usually මම යුනිවර්සිටි ලෙක්චරින් මම මේ විදිහට තමයි කරන්නේ ගොඩක් කරලා ගොඩක් කරලා නැචරල් නැති ගතියක් තියෙනවානේ බෝඩ් එක ලොකුවට වෙන්නේ නැහැ වගේ ප්‍රශ්න කිහිපයක් තියෙනවානේ බලමු right no okay it's a good suggestion okay yeah I know physical method is better I'm not doing anything uh, this well I'm not doing it this is kind of a trial as well for us for our class like if there is any uh, you know extreme scenarios this would be our meeting method so I'll be developing uh, the other part as well sorry other method as well not developing actually I need to go to the location actually go to the class to do this one so the class is closed right now so that's why okay good so let's move on let's write down when electrons are in when electrons are in when electrons are in higher energy levels higher energy levels and energy is not absorbed anymore and energy is not absorbed anymore then electrons will release energy electrons will release energy and move into lower energy levels electrons will release energy and move into lower energy levels move into lower energy levels while releasing energy according to the Planck equation they release some frequency as well if this frequency is within the visible range then human eye can see it as a color can see it as a color. Next bullet point. There are infinite number of energy release energy release ways WAYS energy release ways. Therefore electrons will be in lower energy level than previous. This is creating emission spectrum. This is creating emission spectrum, right? Draw this one. So this is E1 minus E6 equals nu 3. So this is energy is releasing, right? So draw this one. So in this direction, is increasing. This is emission spectrum. So we are talking about only one electron. That one electron can be moved here and there. Infinite number of ways will be there. So it is creating a lot of energy differences, right? Energy level differences. That is the idea. කාටද කෙනෙකුට මේක තේරෙන්නේ නැත්නම් අහන්න පුළුවන් ඈ. Let me know once you're done. No? This is very simple. Okay. How about others still doing? Okay, good. So, thank you. Now let's say we are uh, explaining it further. Now I'm talking about now emission spectrum, not the absorption spectrum. Emission spectrum. That means the electron is in the higher energy levels, right? So when electron is coming from high energy levels to lower energy levels, it is releasing energy. It is not moving into the most possible. It is not, sorry, there is no requirement to move into the energy level which is closest to the nucleus. Sometimes it may be ended up with somewhere around closer to the nucleus. It may be E2, it may be E3. We don't know. It depends on the energy. So there will be series, that's the word, a series of jumps from high energy levels to low energy levels. Depending on these jumps from high energy levels to low energy levels, there are several series identified by several scientists. This is only for the hydrogen emission spectrum. So hydrogen emission spectrum is a series of jumps from high energy levels to low energy levels, because there will be only one electron in hydrogen that's coming from your low energy, and it is absorbing energy and moving into high energy levels and coming back, going back to high energy levels and coming back. So we are talking about an electron and moving in speed of light, more closer to the speed of light. So therefore, there will be infinite number of jumps upwards and downwards. Now we are talking about from downward, or we are talking about downward jumps from high energy levels to low energy levels. Right. So let me draw the diagrams like this. Let's say this is the E infinity one. Right. Then there will be one energy level like this. There will be one energy level like this. And like this. The gap is gradually increasing. Right. Now let's say this is E equals 1. This is E equals 2. This is E equals 3. This is E equals 4. Right? This is E equals 5. E equals 6. Likewise. Right? Now, electrons are in high energy levels and they are moving to low energy levels. So let me draw like this. E1 negative 30. So all right. It's like this. Right? Now there will be some electrons which are moving from high energy levels to E1 directly. That electron can be coming to E1, right, from high energy levels. So it's like this. From E2 to E1, it may be coming back. E3 to E1, it is coming back. E4 to E1, it is coming back. And E5 to E1, it is coming back. So likewise, from high energy levels to low energy levels, it is coming back. The 5 වලින් අතර කරාට තව බහින්න පුළුවන් පල්ලට. So can you understand the energy released in this area, in these lines, are very high because it is coming back to E equals 1, right? So release energy is high means frequency is also high. So these lines are releasing frequency which are in the ultraviolet region. So this is in the UV region. This series is called as Lyman series. Lyman This series is called as Lyman series. We can't see this because this is in the UV region. UV region. So this is how Lyman series is formed. There can be situations where the electrons are moving from E3 to E2, E4 to E2, E5 to E2, and E6 to E2, right? So these are the 4 lines that we can see. These are in the visible region, right? This E2 to E3 is the least energy. Least energy means least frequency. Least frequency means this corresponding to the red line of the hydrogen emission spectrum. ඒ කියන්නේ කොහේ හරි වෙලාවක electron එකක් E3 ඉඳලා E2 වලට පයින්නවා නම් it is releasing red light, right? So the here this one is corresponding to red light. E3 ඉඳලා E4 ඉඳලා E2 වලට පයින් එක it is having green color or blue green color. From E4 to E2 that is having blue color. From E5 to E2 it is having violet color. This total series is called as Balmer series. Balmer series. So this is in the visible region. Visible region. Right? So whenever you ask, no, E2 is corresponding, the red light is corresponding to E2 to E3 jump. So E3 to E2 jump. Green light is corresponding to E4 to E2 jump. Blue color is corresponding to E5 to E2 jump. E6 to E2 jump corresponding to violet color. So this total series, this line spectrum is called as the Balmer series. Balmer series, right? So there can be situations where the electrons are moving into third energy level, right? Third energy level. So let me draw this one. Let me expand this one further. It's like this. There can be situations electrons are moving from high energy levels to E equals 3, like this. High energy levels to E equals 3. So you can understand these jumps are having lower energy. Low energy means they are having lower frequencies. This series is called as Paschen series. Paschen series. P-A-C-H-E-N. Paschen series. If electrons are falling into E equals 3, that is called as Paschen series. This is in IR region, infrared region. There can be some jumps from E equals 4, high energy levels to E equals 4, right? So it can be something like this. E equals 4 equal to him. This series is called as bracket series. Bracket series. Bracket series. BRACKET. Bracket series. This is also in infrared region. That's why we can't see them. Right? Then there can be jumps from high energy levels to n equals 5, like this. This series is called as fund series. Fund, P-F-U-N-D, P silent. This is called as fund series. This is in far IR region. So basically there are 5 series that has been identified up to now. Lyman series, electron jumps from high energy levels to E equals 1, right? So that is called as Lyman series. It is in the ultraviolet region. And there will be a jump from high energy levels to low energy levels, or E equals 2. That is called as Balmer series. Balmer series is having 4 frequencies which are in the visible region. In E equals 3 to E equals 2, it is called as red color. E equals 4 to 2, blue green color or green blue color. N equals or E equals 4 to E equals 2, that is blue color. E equals 5 to E equals 2, that is called as violet color. So the total one is called as the Balmer series. Balmer series. Then high energy levels low, E equals 3, that is called as Paschen series. It is in the infrared region. N equals high energy levels to E equals 4, that is called as bracket series. High energy levels to E equals 5, that is called as fund series. That is in the far infrared region, right? So this E sometimes is called as N as well, right? So in some books, this E is called as N. So N and E, I'm talking about this E, the energy level E, this one. This E is called as N as well, right? N equals 1, N equals 2, N equals 5, something like that, right? So that N is also representing the energy number, right? So let's say I make a N කියලාම දාගමු. ඔයාලගේ පොතේ තියෙන විදිහටම අපි දාගමු. So this is N equals 1, N equals 2, N equals 3, N equals 4. This is N equals 5. This is N equals 6. Right. So this one has been asked numerous times in the examination and your term test as well. You need to be very thoroughly understand this concept. Otherwise, it's very hard to score the marks in atomic structures. MCQ questions are, structured questions are, essay type questions are, you need to be very clearly understand this concept, right? How the fund series is created. Electrons are moving from high energy levels to lower energy level, N equals 5. So that is one series. High energy levels to N equals 4, bracket series. High energy levels to N equals 3, Paschen series. High energy levels to N equals 2, bracket series. Sorry, Balmer series. High energy levels to N equals 1, that is called as Lyman series. Any questions on this one? Right. Let's write down. Complete hydrogen emission spectrum. Complete hydrogen emission spectrum can be drawn as follows. Can be drawn as follows. Right. දැන් මේක පොතේ හොඳට ඉඩ අරගෙන මේක අඳින්න. මම මේක අඳවන්නේ විභාගෙටම අඳින්න වෙනවා. මේකයි. මොකද නිකන් ඉදි ගහලා තියෙන වගේ ඇඳලා තේරුමක් නැහැ. හරියට ඇඳලා පුරුදු වෙන්න ඕනේ මේවා. right? So you mention in this way is increasing. So this is nucleus. Right. Complete එක අඳ ගන්න හොඳ පැහැදිලිව ඔයාගේ පොතේ හොඳට ඉඩ අරගෙන අඳ ගන්න. If I can repeat, complete hydrogen emission spectrum can be drawn as follows. Complete hydrogen emission spectrum can be drawn as follows. දැන් මේක emission spectrum එකක් කියලා කොහොමද හොයාගන්නේ? Because they are coming from high energy levels to low energy levels. And arrow is downwards. So that's why this is a emission spectrum. Absorption spectrum එක මොකද වෙන්නේ? The arrows are coming from low energy levels to high energy levels. So arrows will be in the opposite direction if it is an absorption spectrum. So this is an emission spectrum I'm talking about. So the emission spectrum is coming from high energy levels to low energy levels. Absorption spectrum from low energy levels to high energy levels. Right? Right. Draw this one and let me know. We have to write down many things after this one. මේක ඇඳ ගන්නකොට energy level දෙකක් අතර දුර, the distance will be decreasing when you are going away from the nucleus. එන විදිහට ඇඳ ගන්න. Let me know once you're done. Huh? These names are very important. You need to remember the names and the region and everything. Right? Let me know once you're done. No? Okay, how about others? Okay. අනිත් දෙන්න හැලුණනේ. කවන්නේ. හරි. අපි continue කරමු. Maybe some power connection. Okay. Let's try down. Okay. පුතාලා ලියාගත්තද? ඔයාලා දෙන්න හැලුණා නේද? ඉවර කරාද වැඩේ? Oh, you need time. Right. Let's try down. Above diagram shows electron transitions of a hydrogen emission spectrum. Above diagram shows electron transitions of hydrogen emission spectrum. Next bullet point. When electrons are moving from higher energy levels, to lower energy level to n equals 1, from higher energy levels to n equals 1, high energy levels to n equals 1. Lyman series. Lyman series is formed. Lyman series is formed. The energy of the energy difference. The energy difference. The energy difference of the electron transitions of the electron transitions are higher and the corresponding frequencies are in and the corresponding frequencies are in and the corresponding frequencies are in ultraviolet region. Ultraviolet region. Next bullet point. When electrons are moving from higher energy levels to n equals 2, when electrons are moving from higher energy levels to n equals 2, Balmer series is formed. Balmer series is formed. It has four frequencies. It has four frequencies. It has four frequencies. Invisible region. Invisible region. So write down this table. Electron transition, color, name. Electron transition is n equals 2 to, sorry, n equals 3 to n equals 2. The color is red. This name is, this electron transition name or the line name is H alpha. N equals 4 to n equals 2. The color is blue green. This name is H beta. H beta. N equals 5 to n equals 2. The color is blue. This is H gamma. N equals 6 to n equals 2. This is violet. H delta. Right? Draw this table. So H alpha is red, H beta is green or blue green, H gamma is blue, H delta is violet. Sometimes they ask the questions in this manner as well. Let's write down in the next line. When electrons are moving from higher energy levels to n equals 3, higher energy levels to n equals 3, Parsons series is formed. Parsons series is formed. This is in infrared region or IR region. This is in IR region. Next bullet point. When electrons are moving from higher energy levels to n equals 4, higher energy levels to n equals 4, bracket series BRA, bracket series is formed. Bracket series is formed. This is in IR region or infrared region. Next bullet point. When electrons are moving from higher energy levels to n equals 5. When electrons are moving from higher energy levels to n equals 5. Fund series PF, fund series is formed. Fund series is formed. This is in far infrared region, far IR region or far infrared region. Right. දැන් චුට්ට අහගන්න පුතේ. දැන් අපි මේ එක සීරීස් එකක මේ ලයින් සෙට් එකක් ගමු. දැන් ඔයාලට තේරෙනවද මේ පාෂන් සීරීස් එක? පාෂන් සීරීස් එකේ ලයින් එකේ දිග වැඩි වෙනකොට the length of the line is increased means the releasing energy is also increased because the energy gap is increasing. Energy gap increasing means the frequency will be the highest when the line length is the highest. So there is a correspondence between the line length, energy, and the frequency, right? So when the line length is shortest, something like this, this is the shortest. So in this series, this is having the least frequency or highest lambda, right? So so when it comes to Lyman series, so Lyman series එකේ දැන් මම line 4යි මෙතන හදලා තියෙන Lyman series එකේ. දැන් line 4ක් නෙවෙයි. 4ට වඩා තියෙන්න පුළුවන්. 5. 6 ඉඳන් එකට වදින්න පුළුවන්. 7 ඉඳන් එකට වදින්න පුළුවන්. There are infinite number of lines in Lyman series. Balmer series එකෙත් එහෙමයි. Balmer series එකේ මම 4ක් යනදර පේන 4 යනදර there are some other infinite number of lines will be there. So it is creating the Balmer series, right? So Lyman series, Balmer series, ඔය හැම එකම the length of the line will decide the energy or the frequency. length of the line will decide the energy or the frequency. Right? Higher the length, higher the energy, higher the frequency. So when you um, draw this one like this, right? So we know the lines are getting closer when the frequencies are increasing. So let's say this is H alpha, this is H beta, this is H gamma and H delta, right? So when you check the Lyman series, අපිට පේන්නේ නැහැ. අපිට මේක දැන් පේනවා කියලා. හරිද? අපිට දැන් මේක පේන එකක් කියන එක. හරි. ඒතර පේන එකක් නම් මේක Lyman series එක හෙන ඈතින් තියෙන්නේ. Right? It is in the ultraviolet region. So the Lyman series is somewhere around here. It's something like this. If you can see them, for an example, let's say. So this is the Lyman series. Lyman series again, when increasing order of frequency, the lines are getting closer, right? So this is the Lyman series. This is Balmer series. Partial series is more closer to the Balmer series. ඒ කියන්නේ series දෙකක් අතරත් gap එක වැඩි වෙනවා frequency එක වැඩි වෙන පැත්තට. Frequency එක අඩු වෙන පැත්තට gap එක අඩු වෙනවා series දෙකක් අතර, right? So the Balmer series is somewhere around here. So this is partial series. So in this direction, frequency is decreasing, lambda is increasing, and energy is also decreasing. So Lyman series is in ultraviolet region. This is in ultraviolet region. Frequency වැඩි වෙනකොට series දෙකක් අතර දුරත් වැඩි වෙනවා. And frequency increasing direction, the lines are getting closer. So Balmer series is in the visible region. This is in IR region. So the gap between partial series and the Balmer series is getting closer. Gap between the Lyman series and Balmer series is higher. Right? Clear? Right. Let's try now. The 2D visualization, 2D visualization, 2D visualization of Lyman, Balmer, and partial will be as follows. Will be as follows. Right? Draw this one. So this is the partial series. So draw this structure, total sketch. Or කෙටි ප්‍රශ්න වලට විභාගෙට මේකට මහනවා. Even in A levels as well. right? Hope you have drawn this one, right? Anybody who's doing? Okay. So this is about hydrogen emission spectrum, right? So this one is very important one, and you need to understand very carefully on this hydrogen emission spectrum, right? Now write the topic ionization energy. Ionization energy, right? Okay. අපි දැනට ක්ලාස් එක අපි අද නතර කරමු. ගොඩක් වෙලා ගන්නේ නැහැ. About 2 hours I have taken. So next week we will be doing the class physically in our usual place, Sisipra, Sundays 1 p.m. No change to the class schedule. Next week we will be having the class. So we will be starting from ionization energies next week. So if there are any friends of yours, just let them know. Next week is free of charge for them. That will not be charged for the April month for the next week. So next week, as usual, we will be meeting up physically, right? Okay then. Thank you very much. Have a nice week and hope අවුරුදු හැමෝටම සබ වෙති කියලා හිතනවා. මම අපි ලබන සතියේ. Thank you very much. පෙරවන් සරණයි හැමෝටම.